Hi, everybody. Welcome. It's nice to have you all here today. I know some of you are tuning in from around the world, so thanks a lot for making the time. Our session today is called Under the Hood, the Nuts and Bolts of AI Agent Orchestrators. My name is Melissa, and I'll be your moderator for today's session. So if you guys have been with us for the past couple of months, you would have seen that we've hosted several webinars on AI, covering its impact on product development, businesses, and everyone in the product cycle. Today, we are focusing on agentic AI and how it could change the way businesses run their processes. We've heard terms like carbon and silicon employees and stories of how AI will take over industries. So let's take some time to understand what that really means. And joining us today to help us navigate all of this is Hasit Yagahavita, CEO of 99X. And with his experience in product engineering and AI, he's definitely no stranger. So welcome, Hasit. We're really glad to have you here today with us.
Thanks a lot, Melissa, for inviting me. And I'm really glad to be here with another webinar on this subject.
Great to have you. A quick heads up before we start. If any of you have any questions throughout the webinar, please pop them into the Q&A box at any time, and we'll pick them up later in the session. Okay, so let's get started. So Hasit, we have quite a few listeners who might also be new to the topic of agentic AI and might like to know how exactly what sets agentic AI apart from traditional chatbots and other AI tools we've seen before. So would you care to explain a bit about that?
Yes, of course. When the whole LLM era started, I think a lot of people expected that to be more like a chatbot. I don't think even founders ever expected, for an example, from OpenAI, it to go beyond a chatbot, right? That is maybe that is why probably they had named ChatGPT, right? It was meant to be a chat. So it's an interesting phenomena which has happened in tech space to see another wave of technology leading what is possible. In this wave, what we saw in the initial phases was more like chat applications because it was extremely good in conversations and natural language processing. So people started to use LLM power in getting conversations done on chat applications. It was liberating as techies for us because what we had before that was very limited type of technologies when it comes to chat. However, the technology has matured so much, and chatbots and co-pilots now already feels like a thing in the past. The reason is what you can do with chatbots and co-pilots, although they are fairly sophisticated, they probably might not free up your time as a user, right, or as a human, as an employee in your organization, because still co-pilots and chatbots, they expect humans to trigger a response from them. Mm-hmm. Humans will have to go and ask for some information from chatbots and co-pilots. So they are more like very passive and assistive type of technologies. And there's not much of autonomy because they don't have a goal in their head. They will only respond to what somebody is asking. This differentiates agentic AI, where agentic AI is usually seen as a technology with very high autonomy. You would expect agents to do things with a goal in their head or with some determined outcome in their head. And they typically have an independent life cycle. They tend to live in the background, not just come to life when somebody invokes the agent, but they sort of have an independent life cycle. They can, of course, work in assistive mode, but they are usually proactive. So this distinguishes agentic AI from chatbots. So the two terms I usually keep in my mind always is it an autopilot or is this a co-pilot, right? So if you ask, is it a co-pilot working with the users or can it also be autopilot? If it can be autopilot, then usually we term that as agentic AI.
Okay, very interesting. So for anyone that is looking how to add agentic AI into their processes to streamline their businesses, how would you identify the gaps or the problems that are actually worth handing over to AI agents?
Yeah, that's a very important question for us to ask ourselves. How do we identify use cases? As I said, this era is more like tech is leading. When the tech is leading, sometimes we need to guide the business as engineers, as tech people, to show them how do you start identifying the possible use cases. What can we do more than what we already know or what we are already used to have in the business world? I think this process has to be guided by techies and engineers as much as from the business people. Um, just to understand what the business goal in all of this. Simply, you can say the business goal of most of our agentic effort is in saving human time, letting them do something more human, right? Liberating human capital. So currently, our businesses might look like this 100% workload. What we are doing right now, if we just say what we are doing right now is 100%, the goal is to see can we actually bring it to, let's say, 30%. When you do bring that down to 30%, we need some other layer who is filling in, which we think the agentic platforms and agentic software can help to fill in that 70% of the workload.
Okay.
So this is sort of the business goal, right? But at the same time, with this business goal in mind, you need to relook at our processes, our systems, and question how can I find worthy use cases. I think the word worthy is important here because you can, of course, find use cases, but not all of the use cases are worthy use cases. There are three areas where agentic AI has made a significant impact on today's software. One is on user interaction, how we expect users to interact with our systems. Second one is on process automation, business process automation. And last one is on how intelligent the software is in terms of learning over time, right? I'll explain this a little bit more detail. Like if you think about user interfaces, I think I mentioned this before also at one of the webinars. Sometimes it's interesting to understand that nobody ever asked for user interfaces from software engineers. Like when the business and users, when they came to us with a problem, they never asked for more user interfaces. Nobody said like, I need 10 more user interfaces. They had a problem to solve, but we could not really solve that problem effectively because real world was very unstructured. We couldn't understand the natural language. We couldn't understand emails. We couldn't understand unstructured text or voice or unstructured video feeds, images. And we said, hey, hold on, before we solve your problem, you need to put this messy real world into our beautifully structured databases, right? And then we gave a user interface for you to work with, but not that you actually came asking for a user interface as a user.
Right.
Yeah. So this does not really need to be the same in future. We can stop misusing users as data interpreters and say, hey, probably we can now do our data entry ourselves. We finally understand the natural world, unstructured content. So we are able to automatically extract information from the emails. We are able to automatically extract information from this conversation for us to create notes. And also we are able to engage in a natural and adaptive conversation with the user, right? So this differentiates agentic software to a good extent. Then you are forced to see where do we find use cases in improving interaction. Usually, I recommend asking a catalyst question. That question is, what if, right? What if we remove this particular UI completely altogether from my system? Right? We might not, of course, remove it altogether, but you can actually ask the question by looking at any of the user interface. You can ask this question, what if I remove this user interface altogether?
Okay.
Right. Yeah. And when you ask that question, then you need to find a different means of capturing that data, which that user interface was capturing before. Right? Like an example is order in order form, create new order form. If I don't have that create new order form, that means I will have to actually go to the sources of new orders, regardless of the structure of the sources information. I should be able to extract that order into my system or the data store. Right. So you start looking at all of the different user interfaces in your application, if you already have an application or if you're planning for an application, and ask this question: what if we don't have this?
Mhm.
This is true for user interfaces where you insert data. It holds valid for user interfaces where you configure your data. Like for an example, if you have some configuration user interfaces where you configure rules, for an example, right? So you can go and ask, what if I remove the rule configuration? Is it possible for those rules to be automatically captured when users are using the system? Right? As users are using the system, they might perform certain actions in a particular way. Can I just you look at those patterns, or even have a conversation with the user and capture the configuration needed eventually to execute my logic effectively and efficiently? Yeah. So that's sort of the first area, right? We look at the user interfaces.
Okay.
The second area is to question about the business processes. This is also very, very important. Like one of the things I always find when I ask someone to look at agentic use cases, people look at very isolated actions and say, I have a button here. Maybe I will simply have a prompt and a button instead of just text fields and a button, right? I think we should stop thinking isolated on specific areas, but think more about the whole business process of your application end to end, and ask that. Usually, our business processes are orchestrated by humans. Humans, like for an example, think about hiring a new employee to any organization, and it's the HR team's responsibility to orchestrate that user journey or the business process. What if the person who is responsible for a particular area is not available for some reason? The whole business process will stop.
Yeah.
So these are the areas where you will question and say, instead of having a user managing the orchestration of the business process, can I have an agent
Agent. Yeah.
doing that instead, right? So Melissa, that brings us to another question, like I call these catalyst questions. Another catalyst question asking, what if Melissa goes missing? Who is going to organize all of these webinars at 99x?
Yeah.
And then you think beyond one action to say, hey, maybe the whole webinar organizing process is a business process. There's a way of doing that. There's a way of finding which webinar to organize. There's a process for finding speakers. There's a process for organizing that. There's a process for bringing awareness about the webinar for potential audience. Once we know the business process, we question that is this a business process which could be automated end to end with agents today?
Okay.
Right? You see the difference between looking at actions and looking at the total business processes.
Okay.
That's yes.
Yeah.
Yes, ma'am.
No, I think you mentioned agents talking to each other and stuff, which is something we will touch up again a little later. So, yeah.
Yes, especially it's a good question, right? When you have these business processes, usually business processes are not done by a single person.
Yeah.
So you can actually have other colleagues of you working together in solving that business process. When you say working together, it could be digital employees, other agents, or it could be your human colleagues, right? So there has to be some way of collaborating. We'll touch upon that a little later today. The third area is also extremely important. We have never really created software for last many years which can self-learn and self-adapt and self-improve. Our systems were like this. We have some data, we have some rules, we have sort of a logic in our systems, and it creates a deterministic output. Whereas the future systems are more like the system will actually perform an action, and system is capable of getting some feedback about that action, asking if that action has resulted the desired outcome. If it has not, you can actually change your behavior within the system itself, by the system itself automatically. So how do we find use cases for that? So we look at places where we maintain manual documents, manual rule sets, manual work instructions, where we keep information in people's head. Why do we need to do that when we have systems? Is because our systems are unable to incorporate learning into it automatically. So we need to keep the information outside the system, right? So if you look at all of our policy documents, for example, at 99x, or any work instructions you are keeping at the marketing department, the reason why you have to keep that is the system is unable to self improve, self learn. And
Yeah.
so that is how how you find out use cases um, in uh, in automating that learning. So just to summarize, the question was like, how do you find use
Yeah.
cases? There are three ways we find use cases typically. First, we look at interactions. We ask, do we really need this particular user interface in this format? And then we look at business processes and we ask, do we need, what happens if a user goes missing? Will that business process come to a halt? If if the answer is yes, then we look at automation with agentic means. The last one is, are we keeping information explicit externality to the systems anywhere? If the answer is yes, meaning there's a room for us to improve that system to capture learnings as it performs its operations.
Okay. So just a question to that. In your opinion, what type of processes are like the best starting point for AI agents? Like, is it repetitive tasks or like where human error is more prone or research heavy processes? What do you
Yeah,
think?
I think you need to look at two aspects. One is the amount of manual effort you would save in automating that particular process. That is one aspect, the impact aspect, right?
Okay.
And how much of an effort for us to get this done. That is a low hanging fruit aspect.
Okay.
So highest impact, where you can actually complete that job with the lowest amount of effort, which are sort of low hanging fruits.
Mm-hmm.
Those are the areas you should target first. Yeah, so that is
Yeah.
usually the framework I use for this.
Yeah. Thanks. You also mentioned that different agents have different behavioral patterns and stuff, different roles. So in that case, do all the agents look the same in sophistication, or are there some agents more advanced than others?
Yeah, important question, because this brings us to the topic, nuts and bolts of the agents, right? The question is, what type of an agent do I need to develop for my use case? It's important for us to understand not agents are probably equally sophisticated in what they need to do. They do not need to. It depends on what type of a use case you have. Um, so we at 99x we look at three levels of sophistication when it comes to agents. The first level of sophistication is we call reflex agents. They are more like something has happened. So if you see this diagram here, you can see the agent, and here you can see the external environment. The first type of agents, they are very they just respond to something which has happened outside. Um, that happening in the external world could be a conversation, somebody is asking for some information, or some event has happened, like we received a new order mail, or some other event, or it could be like time based, schedule
So
based.
something has to like trigger it.
Yes, these are actually the triggers, right? Different triggers. So external world has a particular trigger, and when that trigger happens, there's a some sort of a way to for the agent to perceive that, sense that, and the moment you sense it, you simply reason it to find out what should I do now. Someone is asking for a particular report. Which report should I be sending? So you do the reasoning, and then you basically do the action using your tools. And these are agentic tools. And here you have the LLM, and here you have your sensors. When I say sensors, these sensors could be chat message coming in, or some sort of a webhook invocation saying that an event has occurred, or it could be it could be someone is conversing with you, or like time based. I need to do this particular job every 2 hours, right? This is sort of the we call it the most basic type of an agent. Something happens, they are going to act on it.
Right.
Right. Yeah.
Seems.
Yeah. But of course, internally they could be very complex in the type of work they are performing. But the model wise, the model is not very sophisticated. It's just responding to an external event.
Right.
Like for an example, 99x has this agent which everybody knows by the name of Percy. Percy is an agent who's just monitoring all of the events happening in our target market. Like all of the, it reads all of the different news articles or publications online, and look at the event which has happened to see if that event could be converted into a sales opportunity or a prospect, right? But if you look at, I mean, it's a very sophisticated agent. However, if you look at the mechanism, is basically responding to an event which happens outside, and then basically making a decision on what to do.
Right.
Yeah, that's the simplest type. But then agents can be a little bit more complicated than that, or sophisticated than that. Like people, sometimes you have people who are just responding to what happens outside, and sometimes you find people who are not just responding to what happens in the environment, but also have a world view. Like they have a model about things, they have an opinion about things, and a little bit sophisticated agent than the reflex agent is an agent with a world opinion, right? They have an opinion about the state of the world. So still it works the same way. You have some sensory input coming in, and then they will look at their world. Their world could be a simple document. Their world could be a article published, right? That's the scope of their world. They look at the world and try to make a judgment about what is the state of the world right now.
Mm-hmm. Okay.
Right? Yeah, they look at the state of the world and they make a judgment. For that, they might use certain rules to judge if it is optimal or not. Take an example of I'll take the example later in the next slide. So you make a judgment of the world, and then you prioritize certain actions to make the not so ideal state, to bring it closer to the ideal state, in your opinion. Right?
Okay.
So they deliberately take actions to make the situation ideal.
Right. Okay.
So that we call at 99x deliberate agents. The difference between this one from the previous one is just responding to the event, but this
Mm-hmm.
agent usually has a world view, right? Like a model, like an ontology.
Yeah.
They have an opinion.
Yeah.
One of the agents we implemented on this was a legal assistant. Basically, what legal assistant uh, does is they look at legal documents being created, like for example, a legal contract or any power of attorney document, right? That is their world. Their world is legal documents. Right? And
Right.
then when they see there's a legal document in focus, they will basically run their set of rules with their legal knowledge. They have to see if this document is optimal, or do I need to do something on this particular document? Do I need to improve it, or is this good enough? So that's their world view. That's their opinion about the legal document. And then once they find out there could be certain things that needs to be improved, they will work with the user hand in hand or perform certain automated actions to improve the document, which is their world. When I say worldview, it could be
Yeah.
a scoped worldview to that document.
Okay.
Yeah, this is
Interesting.
the second type of way. But we have one more agent, which one more sophistication of agents, which we call goal-oriented agents. They are somewhat similar to the deliberate agent. The difference between this one and the previous one is um, these agents are not acting upon a deterministic set of rules. They
Okay.
are having, they're at least mimicking ambition. They have the ambition to change the world, right? Like, for an example, an agent of this nature could be to say we would like to improve our employee satisfaction.
Mm-hmm.
It's a long-term ambition. And when you have a long-term ambition, they still perceive the world and then they look at the state of the world, and probably they might use some rules for them to understand the state of the world. But beyond that, without just prioritizing and taking actions, to improve things, they do a lot of reasoning. They do what if analysis. They do some planning. They would evaluate plan A versus plan B. Because their goals are long term. Their goals are not just to fix things. Their goals are more like to improve things long term.
Right.
Right? So
Okay.
that's
So,
somewhat similar, but like they look at the problem in a bit of a long-term view.
right. So not just as tasks, but
Exactly.
long-term goals. Okay.
Exactly.
Um, yeah.
Yeah, you
Anything
have.
more?
Yeah. Yeah. Yes.
No.
Just an example, like I mentioned earlier. I mentioned goal of such agent could be to improve employee satisfaction, or in marketing domain or sales and marketing, goals of such an agent could be to improve the brand positioning of a company.
Mm-hmm.
Yeah.
So you'd feed it obviously what it needs to uh, look for or its objectives, what it needs to.
Yes. Yeah, you probably you do not need to feed it because it has tools. When
Mhm.
it does the reasoning, it will use these tools to again get more inputs. Like think about an agent who is responsible for improving 99x brand positioning or any company's brand positioning. Some of these tools could be about um, analyzing online information out there, and
Okay.
using these tools, they might look at the competition, look at their brand positioning, where are they,
Right.
how is the Google ranking of Nine's competitors.
Mm-hmm.
um, so they do all of these reasoning,
Research. Okay.
logic, yes, research. So you don't need to feed all of the information. They are able to basically in their reasoning process, if they think, all right, I need to know about their competition, they are able to make use of the tools to extract those information out from the environment.
Very interesting. Um, So that all seems quite easy enough to understand when you put it that way, but I'm pretty sure it's not as simple to engineer. And we actually have quite a few developers with us today, so I'm sure they would like to know more on the technicalities of how agents are built and orchestrated. So would you mind taking us through the actual nuts and bolts of an agent?
Yeah, sure. I'll skip this when I, okay, let's come to this. Before we look into the internals, um, just on a tab on the time, Melissa, how much time we have?
We have another 15 minutes. Yeah,
Fine.
10, about 10
Yeah,
minutes.
that's nice. That's nice. So before we look at the internals of the agent, you also need to think about where are they positioned in the enterprise architecture or in your system architecture. So this is a fairly simplified view. You might have multiple different front ends or micro front ends in your enterprise or in your system, and then you have your back end, probably a set of services, and in between you might have certain service layers. Usually agents, they sit in the service layer. So the front end applications, other than simply using the traditional conventional service layer, they will come to a agentic service layer where agents are performing certain work and providing information back to the users. So this is where usually agents fit in a system architecture or even in the enterprise architecture.
Mhm.
Having said that, we can now look into a bit of internals of an agent. So if you take a look at agent A or agent B, all right, okay, I forgot about the MCP layer. You can also usually, if you have external agents using your services, you can place an MCP layer. I think a lot of the techies, they already know what an MCP layer is. Simply, MCP layer is a protocol similar to APIs for agents to consume functions or services. The MCP could be on services, or you can also have MCP type of a layer on top of your agents also. Usually when you have it on the agents, we call it A to A, agent to agent. But if the agent is using a set of services, we use the MCP as a protocol. All right, looking into an agent, like I mentioned about Percy before. Percy is an agent where our sales and marketing team is using to discover new prospects. So the responsibility of the Percy is to go out, look at whatever the information available online, read news, look at articles, look at our target market segments websites, and see if there are anything interesting happening. If they find something is happening out there in the market, they will look at that event and see, can we convert this event into a sales opportunity. An example event is one of our target market prospects getting a large investment to build their new generation AI suit. right? That's of course an interesting opportunity for 99x. So the responsibility of the Percy is to monitor these events and then create reports and inform back our sales team. So this is fairly sophisticated work, even though it sounds simple. One of the things Percy has to do is Percy has to be extremely good in web handling. Web handling is somewhat complex and very uncertain at times. So you need a lot of tools like web crawling capabilities, web reading capabilities, web automation capabilities, like for example, navigate across a website to find more information. You need search capabilities. So without building all of that into a single agent, we in our architecture, Percy is constructed as a set of agents. So we have a web agent who is extremely capable and knowledgeable of how to deal with the web, extracting information from the web. And then you also need another type of a capability where Percy is able to interact with the users through Office 365 ecosystem like emails or chat. And also you need to do certain utility functions like generating PDF reports and all of that. So we use another set of MCPs and put that onto another agent, which we call the report agent, which is capable of basically navigating through Office 365 Graph API to find users, send chat messages, send email messages, or even engage in a conversation with 99x marketing team. And that is also A to A, agent to agent type of a, yeah. You can see now how these different protocols like A2A and MCP, they all come together in creating a sophisticated agent. But it's not only that. Percy is, other than interacting with users, Percy has its own processors. Like it has its periodical processors. It will go out online to find information, extract information, discover articles, discover news. So that's a different agent. It works on a schedule. The moment you discover anything interesting, then it is put into a workflow for the validation, for report generation, for emailing. Um, so in Percy, for every link it discovers, we create a short running workflow which will do all of these validation processes and finally contact users and inform our marketing team regarding the event which has happened. Yeah, so some of these tools are using the same MCP tools, like the interaction agent and all of these article workflow agents. They're using the same set of tools, which is making use of two other agents. These two other agents are making use of several MCP tools like API tools. So that is more like how you could construct a fairly sophisticated agent. And this one is still L1 agent.
Yes. Yeah,
Right? You
that's
don't
what I was
really
thinking.
have, yes, you don't really have all of this sophistication of understanding users and memorizing things and learning automatically in this agent. But when it comes to L2, L3 agents, things can be much more complicated than this architecture. Yeah. Do we have
So
questions from the audience?
yeah, hold on. Let me
Not
check.
yet, at least.
Yeah, nothing yet. We are We are running a little low on time, so I'm not sure if you have a lot of time to answer this. So maybe you could quickly run through this. I think you've been one of the key people behind building our open source platform Agentry, which Percy is built on. I've seen several new engagements as well where we've extended Agentry into products and applications. So could you just share why and how having an underlying platform like Agentry helps in developing new products, like the
Yeah,
importance of the platform?
yeah, sure. It's important. Like when you look at what is needed to build agentic applications, as I mentioned earlier, we need to build capabilities in how agents are interacting with users, how agents are executing business processes, and how agents are capable of self-evolving, self-learning over time. And there are many areas where you need to get a support from a platform, because if you have to do all of these different um, concerns, architectural concerns, by yourself for each and every use case you are implementing, it could actually be it could become unmanageable within your organization. So we need to think of sort of a platform approach, where you will say these are common concerns of all of these agents. Why don't we build the platform and use the platform features to build our agents on top of it? My chairman, maybe I can take that call later. Right. Yeah, so if you go to this particular link, you will find more information and more concerns like this, architectural concerns. So the idea of building CN's platform is for us to help our customers to navigate this space and make use of these already ready-made, already built functionality in all of these different areas of concern.
Got it. Very interesting. I think we've run into our Q&A time, but since we don't have any question, oh, hold on. I think we have a question. Um, we've got a question that says, can you explain Percy's workflow in a little bit more detail without going, how is Percy getting data and using news APIs? How is the
Yes.
marketing team notified? An email
Yes.
sent. Yeah.
Yeah, exactly. I can do that quickly. Let me see if I can find Percy here. Right, yes. So Percy uses several APIs, because you also need to do this um, in a legal and ethical manner. For an example, if you have to do Google search, you can't scrape the web for Google search. You need to go through some sort of a API. Mostly are paid APIs. So we do use scraping tools, which has the ability to respect robots.txt files and terms of use on the websites, on target websites. So it's capable of basically using all of these different tools, which we integrate them through MCP protocol here. You can see it's able to perform fairly sophisticated work online, do a complicated or do some advanced research on an event which has occurred online. And once it's done with its research, which is mainly through online data gathering, it's able to communicate with our sales and marketing team over email or over chat. And there's one more tool which is not actually shown here. Percy is capable of manipulating data in our systems like HubSpot, because we use HubSpot as our CRM. Once Percy finds a prospect, it can take a conversation with our sales team, and if the sales team is happy with the prospect and if they think it's actually a valid prospect, the Percy is capable of going and updating our sales pipeline and add that as a sales prospect into our deals pipelines. Yeah, so that is how Percy operates with humans as well as on the web part of it.
Thank you for that, Hasit. I think, all right, we've got some shout outs for you, Hasit, but I think that wraps up most of it. I think there's a bunch of questions I had, but I think we are a little low on time. So
I'll
maybe we
quickly
can.
take one more question. There's a question asking, are you using low-code tools
Low-code
like
tools like,
yeah,
yeah.
N8N? We are not using N8N. We had been using N8N some time back, but the type of agents we are building, it's extremely difficult to build it on a low-code drag and drop type of a user interface, because these are, I would say, very complex agents. So you only way you can build is by using code, but we use a workflow engine called Temporal. If you know Temporal, it's sort of the de facto in complex workflow handling. We don't use N8N, but we use Temporal. The reason is Temporal allows us to actually code business processes, business workflows without using simple drag drop interface. So N8N, we have used it in certain projects, but it doesn't help the type of complex agents we are building. So we are building agents mostly on code using Temporal. Yeah.
All right. I think there are lots of questions we all have, but we are out of time for today. So maybe we could probably get you for another webinar sometime soon to discuss the rest. But thank you so much for actually taking us through how AI agents can be orchestrated and in real business settings as well. So thank you for hanging out with us. We'll actually be sending over the recording and some bonus resources as well. So everyone can keep an eye on their inbox. We've also got some more interesting sessions coming up. So don't forget to register and bring a friend and follow us on our social channels to stay updated. Thank you again, everybody, for joining. Thank you again, Hasit, and see you all next time.
See you all soon. Bye.